So you want to make a change to OSM core source code. So we have a life cycle of a patch. The first thing that happens is you will check out the source code. You will take a look at it, read it through, figure out what you want to change, make the change, and then submit it to Garrett. And we'll get into the details of how you submit it to Garrett a little bit later. Right now, we're just talking about the high-level workflow. So you go ahead and you propose a patch to Garrett. Next, what happens is it gets verified by Jenkins. So Jenkins wakes up and runs a bunch of stuff and does a bunch of stuff, and it says, okay, so far so good. It compiles. None of the tests broke. Let's see what happens next. It gets peer reviewed. This is what's done inside of Garrett, where people can comment, post their feedback, and ultimately it will get approved, which is what we call a +2 by the module development lead. So in Garrett, mere mortals, if you will, regular users, regular contributors have the ability to vote +1, 0, or -1. +2 and -2 are only available to MDLs, and a patch will not be able to be merged without at least one MDL giving it a +2. So that is what I mean by it's been approved, or we've got the +2 by the MDL. After that happens, another MDL, make sure that I've defined that, module development lead. Those were the names that I called out in that previous slide. So next what happens is it gets merged by the MDL, and then a daily full suite verification job will happen at some point during the next 24 hours, or depending on when it was submitted, it'll happen. Then it gets published to Docker Hub. After the daily suite runs, the code is published to Docker Hub and it becomes available to anyone for installation. So proposing a patch. How does this work? You make your change locally. You run talks on it. I happen to have put this one here, talks-e cover, which runs all of the unit tests. But there are other targets inside of talks that will be used by the build process. So it's strongly encouraged that you take a look. We'll get into it. There's a script called stage test, but whatever is inside the stage test script is the suite that Jenkins will run, and you should run this locally before pushing your review. Otherwise, you may find that you've published your review, and within a couple minutes comes back and says, "Oh, a test failed," or "Oh, your formatting is not PEP 8 compliant," which is a standard for Python code. We also need to make sure that we have the Apache license present in all of our files. We only check files that have been changed in a review. So it's entirely possible that you're going to make a change and all of a sudden Jenkins says, "Oh, you're missing a license file." You're like, "But this file has been here for 2 years. Why are you telling me? I'm just making a one-line change in it." Well, that's because we only started enforcing our license check 2 years ago. And if the file happens to predate that and you happen to make a change in it, well, then unfortunately, we ask, please, for you to put the license in there if it's discovered to have been missing. If you do add a new file, we do need to make sure license is present in it. Exceptions are made for things like a JPEG image or certain, I believe, JSON or some other markup languages do not support comments. So any language that doesn't support comments, you won't be able to put a license file in, and that's understood. We have an exception for that. Then we start a review. You do that by issuing the git review command. And once you do that, it'll be available in Gerrit, and the CI/CD pipeline will start up from that. So here is an example of output from Gerrit. We can see, oh, you know, Fabian happens to have uploaded a patch, and Jenkins then comments, hey, I've started a build for this patch. What happens after that is Jenkins wakes up and goes through a series of build stages. The first stage prepares an environment, basically checks out the code, gets things ready, and then creates a stage 2 job for that. The stage 2 job will create a Docker container for the purpose of running tests. This Docker container comes from the module itself. Each module will have a top-level Docker file, and it is used for the sole purpose of executing tests and creating the package for it. So it runs this DevOps stage test in the Docker file, and it runs DevOps stage build, which will create the Debian package of the software, you know, basically the Python libraries, the Python source code that was changed. This package contains your change, and it is uploaded to a product we call Artifactory, which is what we use for holding all of our intermediate software versions. The last thing that happens is a stage 3 wakes up or gets triggered, and every module shares the exact same stage 3. So it's a common thing. Here I was showing, you know, the output from Jenkins here, where you can see it says, okay, it's going to run the stage test, runs the stage build, and here is some example output. This Artifactory OSM is actually a link that you can click on, and it will take you right through to Artifactory, where you will be able to see the artifact that was built that contains your source code change. One of the things I'm going to do here is I'm just going to quickly take us over to Jenkins, the dashboard, and I'm going to take us over into Gerrit so that you can see what things look like. So this is, at a glance, the main dashboard for Gerrit. There are two ways of viewing Gerrit. This is their new modern UI, and down here at the bottom there is this old UI. So if you have used Gerrit before and you're used to seeing things a certain way, you can try switch to old UI, and that may, you know, may make it look more familiar. I happen to be more familiar with the new UI and I'm comfortable with that, so that's the one that I use. So here now we can see that there is a change: subscription, API, commands, and library. If we go into that, you can see the way it works is that here it lists the files that have changed. Excuse me. And here is the file change itself. Actually, this was not the best one that I could have picked as a change. Oh, here we go. Here's a bug that's being fixed. So here you can see some people have voted on this. They've given it +1. Jenkins has also voted on it under the verified label. Here, when we go inside, you can see, oh, here's some content that has changed. So on the left is what it used to be. On the right is the new change. And at any time, somebody can go in and make a comment and go, you know, oh, I really like this. And then we can save that comment and other people can, you know, reply to that. So that is what Garrett looks like. And as you can see, there's a series of conversation that comes down here. Here's an example of Jenkins saying, uh-oh, this build failed. And then later on, Subankar has uploaded a new version of this file. And Jenkins woke up again and said, oh, okay, well, I'll try a build of that. And finally, it was successful. And then other people are voting saying, yes, now it looks good. We'll go ahead and do that. Here you can see an example of what the comments look like. I agree, it makes more sense. The content is modified, etc., etc. So to take a look at what Jenkins looks like, here is, let's start with this. Here is the stage 1 that I talked about. It tells you why it happened. So we've got a link both from Garrett to Jenkins and from Jenkins back to Garrett. You have to go into the console output so that you can see, oh, here's the stage 2 job that was triggered for it. So we can go into the stage 2 job and it tells us some information about what happened. We've got 39% of the lines were covered by unit tests. There were no test failures. You can browse the test results directly in here, and you can see the tests that were run, how long they took. If any of them failed, they would be highlighted here. We can also go in and see the actual coverage report. So there's a bunch of things that go along with this. Then you go into the console output again, and this takes you through all of the code that executed in order to be able to build this. So here we can see it is running that stage test. It's running through all of our tests, producing the final coverage report. Does Flake 8, which is a Python static code analysis to make sure that it's all, you know, formatted correctly and there isn't any obvious errors with it. And then it builds a Debian artifact. Here it gives you the link to where that Debian artifact is published. And then it starts this common stage 3 job. This stage 3 job is a much longer one. And I will now go and explain what happens during stage 3. So when stage 3 wakes up, it pulls the latest published version of all the other modules, not the one that you changed, but all of the other modules from Artifactory. So Artifactory not only contains your intermediate change, but it contains what we'd call the last known good version of all the other modules that have been built. It then pulls down your local changed version, from Artifactory. So it now has the latest, best version of all the other modules, plus that one change that you made. It then goes through and builds the Docker containers for all of the modules. It does this using the DevOps Docker files for the specific modules. So there are 2 Docker files that each module will have. One is for the sole purpose of executing tests. The other one is located under DevOps, and its purpose is to create the final Docker image that will be used at install time. It pushes all of these Docker containers that it built into our internal GitLab repository. You can actually install OSM from these internal build versions. So if you've made a change and it's been submitted, and it went through the before it's even been submitted, you have started the review on it, and the stage 3 has run, that will be available in the internal repository, and you can install OSM using that change you made even before the code has been submitted. Before an MDL gives you +2, you have an opportunity to change it, or to test it, I should say. So all of the Docker containers are published, then a new VM is launched, and we install OSM using those Docker images we built. So here's an example of the install OSM command. It says what what apt repository to use for Debian packages. And here it says what tag from the osm-etc.org internal GitLab repository to use. So this tag matches the build number that's currently in progress. And this is the tag that you can use to fetch that Docker image to your local environment for local testing if you want to actually try it in an end-to-end environment. Or if somebody else has made a change and they say, hey, could you test this out independently for me and make sure that it works? Then, on completion of all of the stages, Jenkins will vote +1 on the verified tag in Jenkins. So you can see here, the patch set has got a verified +1 on it. If any of the previous steps fail, you're missing a license, code was improperly formatted, a unit test failed, the Docker images couldn't be built due to some sort of dependency issue. Maybe the Docker images were built, but when OSM got installed and everything went to run together, it discovered that, well, something fundamental broke that prevents OSM from starting up. If anything fails, Jenkins will vote -1 on the verified. And anything that contains a -1 cannot be submitted. So, what is the approval to merge? As I mentioned, only MDLs may vote code review +2. The requirements to merge are we must have at least 1 +2 and 1 +1 in verify. So here's an example of a patch that's ready to be submitted. We can see that 2 people have voted +1 and an MDL, or in this case TSC member, has voted +2. Also, Jenkins has verified it. So that means we can go ahead and submit it. Now, comments can be left by anyone. These comments can be improvements, changes, suggestions. This is entirely a dialogue. This is anything that we want. It can be a place to ask questions as well. You know, you've made a change and you're not sure. You just want to be able to say, hey, why is this happening here? That's certainly valid in a code review as well. An important thing on these code reviews, don't take it personally. -1 is not an insult. -1 does not mean that you failed. -1 simply indicates that the code needs improvement. It's a conversation. It's not a grade. This is just a way of being able to indicate that, unfortunately, you know, the code as it stands can't be submitted. I know that in OpenStack, where they use Garrett as well, -1 is used fairly frequently, and it's just simply, no, we you know, a way of being able to say, we need to work on this, we need to continue with this. So -1 could be seen as a positive thing. It means that people are looking at it. People are helping you move forward. So next thing that happens is the post-merge pipeline. Stage 1 and Stage 2 repeat, but Stage 2 is a little bit different. It doesn't publish in Artifactory into a staging place. It actually publishes this last known good version of the module. So when TSC, I was reading the comment, my apologies. I'll get to your comment question in just a moment, Wajia. When code is submitted, a build happens, the Debian artifact is created, and that's published as the latest good version of that. So when other patches go to run, they're going to use this version to test themselves against. Note that this software exists only in Artifactory right now. It's not available in any public Docker image. So no one's going to be able to, update their existing OSM installation to have your code fix or new feature at this time. So I see the question is, when is TSC needed to approve code? The TSC must approve any changes to the information model or the northbound interface. No one module development lead is allowed to make changes to those two critical pieces of our infrastructure. Any changes in information model, any changes in our northbound API have to be approved by the TSC. So that's when they get involved. Last thing that happens in the overall build pipeline is the daily job. And this wakes up on a fixed schedule and performs a stage 3 build. We saw the stage 3 before. What it did was it, gathered all the versions from Artifactory, built Docker containers, and performed installation in a new VM. How is this stage 3 different? Well, it's using the last known good published version. So throughout the day, there may be several changes that happen, several stage 3s that run. Some of those changes are submitted, some of them not. Only the ones that are submitted get promoted to this last known good version. And that is what is consumed by the daily job. So once a day, the most recent good version of the software is all collected together. We install it in a new VM. We run a full sanity suite against it to check its functionality. In the main line of the code right now, we've got 288 tests. Once these tests have finished and it's run through all of it, it then turns around and publishes those images to Docker Hub. So once it's available in Docker Hub, then anybody can use those images to install OSM in their own environment or upgrade their containers to be at this new version. So once a day, we publish our new versions of OSM, and once a day, you can consume them to get the latest bug fixes. And that is the workflow in a nutshell.